Hi, students. Today we are going to cover section 7.6, which is proportions and work and distance problems. These are going to involve a lot of rational equations. So we're going to be solving rational equations, multiplying by the LCD, and we're going to learn a new technique which we can use to solve proportions, which is called cross multiplying. Some of these problems are really simple and you guys might be familiar with them, but when we get to the work and distance problems, those are multi-step problems that you really have to think out one step at a time. And I'll give you a technique for both of those. So let me share my screen with you guys. And today we're going to be working from a PowerPoint, which is kind of nice because the graphics are a lot better than just me drawing on my whiteboard. Okay. So proportions and work and distance problems. First, we want to start by defining what a ratio is. A ratio is a quotient of two numbers or quantities. For practical purposes, it's going to be a fraction. So when two ratios are equal, we say that they're proportional. For example, we'd say that 1/2 is proportional to 4/8. Okay. Sometimes we have a proportion problem when we have one piece of those four pieces of our fractions missing. So for example, if we had the proportion 1/3 equals x over 9, and we wanted to solve for that x, this would be a proportion problem. There's two ways to solve these problems. We can approach it just like any other rational equation and multiply by the LCD of the denominators of all our fractions. Or when we have this specific case where we just have a fraction equals another fraction, we can shortcut that using what's called the cross product. And basically the cross product is a shortcut of multiplying both sides of the equation by both denominators. The cross product works really well when you have smaller denominators, when you don't want to take the LCD. It doesn't work as well when you have a pretty big LCD because then your numbers just get a lot bigger, but it always works. So using the first method, if we want to multiply by the LCD, we see that our LCD here is 9, and that's because 3 is already a factor of 9. So we'll multiply both sides by 9. On the left-hand side, you see that the factor of 3 in the denominator cancels out with the factor of 3 in the 9. And on the right-hand side, the 9 in the denominator cancels out with the other 9. And so it very quickly simplifies to 3 equals x. And you can confirm by looking at the original equation that 1/3 is equal to 3/9. Okay, so that's the multiplying by the LCD method. If you want to use the cross product method, that's where we multiply the x times the 3, and we set that equal to the 1 times the 9. Essentially what we're doing is we're multiplying both sides by 3, and we're multiplying both sides by 9, and then canceling out the denominators there. Okay. This just leaves us with one extra step where we then have to divide both sides by a factor of 3 to get that x equals 3. So as you can see, the cross product works just as well as multiplying by the LCD. The only difference is if your denominators share common factors, when you do the cross product method, you're going to have to divide by those common factors later on as you solve the equation. Let's do one more example with just a little more complicated proportion. Here we have 3 plus x over 10 equals 6/15. Okay. In this case, we can see that we have an LCD of 30. For something like this, where I can see the LCD really clearly, I prefer to just use the LCD method. If you can't see the LCD as clearly, then sometimes cross multiplying can be faster. In this case, if we cross multiplied though, we'd end up with some pretty big numbers. 10 times 6 would be 60. So that's why I chose the LCD, but both work. So I multiplied both sides of my equation by 30. I use that. The first thing I do before I distribute the 30 is that I make sure that that 30 is going to cancel out with factors in my denominator, right? The factor of 10 in the denominator cancels out with the factor of 10 and 30 and leaves me with just a 3 I have to multiply through on the left-hand side. And on the right-hand side, the factor of 15 cancels out with the factor of 15 and 30 and leaves me with just a 2 that I have to multiply through on the right-hand side. After multiplying through and simplifying, we'll get that x equals 1. Okay. You can work through that problem on your own and do the cross multiplying method and just kind of compare how you have to do slightly different mathematical steps, and you'll understand how to best choose which method to use depending on what problem you have. But both of them will always work when you have proportions. Sometimes we have word problems where we have to set up our own proportion. And in most of the word problems with proportions that you're going to come across, the math is not the hard part. Really, the tricky part is making sure you're setting up the proportions correctly. There are a lot of correct ways to set up your proportion, but there's also some incorrect ones. Okay. So in our word problem, this is a problem I come across quite often when I'm shopping. Let's say a 12-ounce soda costs $1.25. And how much should we be paying for a 20-ounce soda? And when I say how much should a 20-ounce soda cost, I mean if the price per ounce of that soda is the same, what should a 20-ounce soda cost? And then you find yourself oftentimes at the store where the 12 ounce is $1.25 and the 20 ounce is, say, $2. You know, are you saving money by buying the bigger size, or are you not? Okay. So the way we can set this up is with a proportion problem. We want to figure out proportionally what a 20-ounce soda should cost if we're paying the same amount per ounce of soda. Okay. So we can set up this equation in 2 ways, really more than 2 ways. What's important here is that the same things are always directly above or directly across from each other. Okay. So in our first example here, we have the ounces in the small soda over the ounces in the big soda is equal to the price in the small soda over the price in the big soda. So ounces are above ounces and the sodas are across from each other. Okay. In our second setup, we have the price is across from each other and the same soda is in the same fraction. Okay. So I circled stuff here so you can see similar things need to be across from each other. Here, the ounces are either across from each other or directly above each other. And the soda itself, so the small soda, is either on the top or in the same fraction. So things that are the same, meaning same units or same item, should never be diagonal from each other. Okay. So either way you set it up, you can cross multiply and get to the fact that our X, which is what we think a 20-ounce soda should cost, is $2 and a little more than 8 cents. So if they're charging $2 for a large soda, technically you're saving a tiny bit of money per ounce by getting the bigger soda. Okay, but it's not a huge discount. Right. Another place we come across proportions is when we look at similar triangles. So similar triangles have the same shape, meaning the same angles, but they're a different size. So similar triangles are basically like a picture that's been zoomed in, right? Everything is still proportional. It's just either bigger or smaller. So once you know that two triangles are similar, like in these two in the example, we just set up our proportion and we can solve for the length of that final side. Just like with the word problem we did before, you have to make sure you set these up correctly. So we can set it up that the same sides go into the same fraction and that the same triangles are across from each other. So in the first problem, we've got our first triangle vertical side over our second triangle's vertical side equals our first triangle's hypotenuse over our second triangle's hypotenuse. Okay, so notice same things, same triangles are across from each other in our first example, and same sides are vertical from each other. We could also set it up the other way. So 2 over 10 is the same triangle same triangles are above and below each other, and then across from each other are the same sides. Okay. So you can set it up either way. When you cross multiply, you're going to end up with the same thing. 2x equals 3 times 10. We'll multiply that out, divide by 2, and we get that x equals 15. And then you can go back to that problem and kind of look at it. This one is easy to see. All right, if our side went from 2 to 3, and our other side then is going to go from 10 to 15. Okay. So the setup is important, and I think in the similar triangles, it's easy, maybe a little bit easier to understand what I'm saying about either same sides or same items have to be vertical and horizontal from each other. Some of the problems you guys are going to come across are just straight number problems here. Some people have the most trouble with these number problems just because there is really no context for them, but also because some of the words are a little bit different than we're used to seeing. So I'm just going to go over these, what I call grouping words, but they're actually just mathematical operating words. So we've got quotient, which is going to take, anytime you see the word quotient, it means you're going to take the two things that they say are in the quotient and make a fraction out of them. Okay. Anytime they say product, you're going to take the two things and multiply them. Anytime they say sum, you're going to take the two things and add them. And anytime they say difference, you're going to take the two things and subtract them in the order that they list them. Okay. Then the idea is when we refer to the quotient, product, sum, or difference, we're referring to that whole math process. So the quotient is referring to that entire fraction. The product is referring to the two numbers that have been multiplied. The sum is referring to that whole addition, and the difference is referring to that entire subtraction. Okay, so sometimes when you see these grouping words, it might be helpful for you to just put parentheses around the two numbers that go inside this operation. Okay, so let's do a little quick example of each of them. So the first example here, the quotient of a number and 3 is added to 2. So if we want to translate this into mathematical symbols, the quotient of a number and 3. So when they say the quotient of a number and 3, we have to realize quotient is grouping a number and 3. When we don't know what the number is, we give it a variable. So the quotient of x and 3 is going to look like x divided by 3. That thing that they've just grouped for us using the word quotient, that x over 3, then gets added to 2. So it looks like x over 3 plus 2. Okay. For product, the product of a number and 3 is added to 2. In this case, our number, we're going to call x and 3. Since it's a product, it's going to be 3 times x, and that's being added to 2. So 3 times x plus 2. Keep in mind here, the product of the number and 3 is what's being added to 2. So we're going to take that product first. We're going to do 3 times x before we add the 2. Okay, so that's why I don't have parentheses here, or if there were to be parentheses, it would be around the 3x. Okay. Now in our third example, the sum of a number and 3 is multiplied by 2. So here, this sum is grouping the number x and the number 3. So we're going to add 3 plus x, and that happens before it gets multiplied by 2, because the thing that is being multiplied by 2 is this sum. So the sum here is in parentheses x plus 3, and that sum is what's getting multiplied by 2. So the word sum groups the x and the 3 so that the x and the 3 in their entirety get multiplied by the 2. Okay. In our last example, difference, the difference of a number and 3 is multiplied by 2. Same thing here. A number is x, so a number and 3 is going to be x minus 3, and that gets grouped by the parentheses before we multiply by 2. So when they say difference of a number and 3, always put the, since they list the number first, we're going to do the x first minus the 3. Okay. So that's how these grouping words work. Make sure you really understand they're grouping words, meaning quotient, product, sum, and difference. When you're asked to do something to a quotient, product, sum, and difference, you want to know that you need to put parentheses, if necessary, around the 2 pieces of information that go into your quotient, product, sum, or difference, and then do it to that whole thing. Okay. Let's do one a little bigger example, and this is a pretty complicated example, but I wanted to go over one of the more complicated ones for you. 5/3 is subtracted from the quotient of a number and 6, resulting in the quotient of the number and 2. If you want, go right in here and cross out number and put an X over it, okay? So that you can kind of get your hands on the symbol that you're going to use when they say number, right? So when they say 5/3 is subtracted from the quotient, that means 5/3 is going to get subtracted from something that has 2 numbers in it. So the quotient is of a number and 6. So our quotient is x over 6, and we're subtracting from that the 5/3. Remember, when you subtract from, you start somewhere and then you subtract from that, okay? When they say resulting, we are resulting in, that means equals the quotient of the number and 2. So we're going to do the quotient of the number and 2, which is x over 2. Okay. If you want to work through, if you want to pause the video here and work through that language on your own, that's a good idea. So now let's solve some problems about work. We have 2 types of problems that we're going to solve here. We've got work problems and we've got distance problems. You're going to want to make sure you identify which of the 2 problems you have before you get started, because I'm going to give you different techniques to solve each of them. Okay. So this problem is about work because it's things getting done over a period of time, okay? In this example, it takes Sam 3 hours to put together an IKEA desk if he does it by himself. It takes Adam 7 hours to put together that same desk if he were to do it by himself, okay? Now let's say Sam and Adam work together to put this desk together. Obviously, Sam is going to get a lot more of the desk assembled than Adam, but how long, if they both work start to finish, will it take the 2 of them to get this desk put together? okay? This is a little bit of a tricky question. So there is a technique for solving these problems about work that is really simple once you see it, okay? So the trick is that you want to break the work done into 1 unit of time, okay? So here it's in hours. So we're going to say, how much of the work can Sam get done in an hour? Well, if it takes him 3 hours total, he can get 1/3 of the work done in just the first hour. But in that same amount of time, how much of the work can Adam get done? Well, since it takes Adam 7 hours to put this desk together, in the first hour of working together, Adam's going to get 1/7 of the work completed, okay? So in just 1 hour, Sam will get 1/3 done, Adam will get 1/7 done, okay? But then what we really want is how long is it going to take them if they work together? So we're going to call it X hours. It takes them X hours to complete this task together. So in 1 hour, they will have completed 1/X of the work, okay? Where X is the total time that it takes. So we can set up an equation that isn't directly about the total time, but the total time is in there. So in 1 hour, we get 1/3 of the work is going to be done by Sam. 1/7 of the work is going to be done by Adam. And in 1 hour, we're going to also have completed 1/, the total hours it takes them together. Okay. So the 1/3 plus the 1/7 is the fraction of the desk that they've completed in an hour. And if it takes them X hours to complete the desk, then 1/X is the fraction of the work that they would have completed in 1 hour. So that's how we can set those two things equal. So it comes out to be a really nice looking equation. 1/3 plus 1/7 equals 1/X. Okay. And when you set up these work problems, it's always going to be 1 over something. So when we go to solve, we're going to have to multiply by the LCD, which in this case is 3 times 7 times X. We multiply everything by that. Remember to distribute on the left-hand side the 3 times 7 times X. Cancel out all your denominators. And then you can solve this equation to get that X is 21/10. So what that means is if they work together, it'll take them just over 2 hours. Okay. And you can kind of look back at how long it takes each of them. It takes Sam 3 hours to put together the desk by himself. It takes Adam 7 hours. So like Adam's helping a little bit, but he's so much slower than Sam. He's really only cutting down a little bit of the work for Sam, and Sam is still doing most of the work because he's just that much faster. Okay. But the key part of this is to realize you have a work problem, and then to remember this really kind of cool solution method where you break the work done into 1 unit of time. Okay. And so you can show the fraction of the work completed in an hour by each person is going to equal the fraction of the work completed in the total time it's going to take them together. Definitely, if you want to pause that one and come back to the solution and really understand how that solution works, you can do that. All right, our last example today is going to be distance, rate, and time problems. So these are also word problems, and you just want to be very careful to make sure that you don't confuse these with the work problem that we just did, because they may sometimes seem similar, but you want to recognize them as different because our solution paths are going to be very different. So in a distance, rate, and time problem, we're we're going to have to make a chart and we're going to have to set things up before we jump into our equation. Okay, don't try to jump into an equation without really making sure you've mapped out everything that's happening. Okay. In our example here, a car is going to travel 180 miles in the same amount of time that a truck travels 120 miles. Okay. Then they tell us that the car is going 20 miles per hour faster than the truck. And the question asks, what are the speeds of the car and the speeds of the truck? In these distance, rate, time problems, we are always going to use the fact that speed is distance divided by time. Okay, speed is distance divided by time. You can rearrange that equation to solve for time or to solve for distance. Okay, but always be able to find the speed, the distance, or the time. If you're given any two of those, you want to make sure you're able to find the third. Okay. So these problems are going to follow a set of steps where we have to really kind of map out the information that we have. First, we want to list the stuff that we know, and we want to set a variable for our unknown. Okay, in this case, we have two unknowns, the speed of the car and the speed of the truck. So we need to make one of those an x. And in this case, the other one can be an x plus 20. We want to use this chart over here, fill in all the blanks. And then finally, the final trick to getting our equation here is that they tell us that they're going, that they do this process in the same time. So something's going to be the same. They're going to tell you in your word problem that something is the same, and that's where you set those two things equal. Whatever things are the same, we're going to set up as equal. Okay. But obviously, we know they do this travel in the same time, but what's the time, right? Well, we use our chart and the fact that speed equals distance over time to fill out all of these pieces of information in our chart. So first, we do know the distance. The car goes 180 miles, the truck goes 120 miles, okay? And we do know the speed in a way. The speed of the car is 20 miles an hour faster than the truck. So if we let the speed of the truck be x, we can call the speed of the car x plus 20. We could also say the speed of the car is x and the speed of the truck is x minus 20. You can do that. You just have to remember what is x, right? Because we get to assign our variables. So in the end, when you go to answer, you have to remember which one x was. The reason I like to choose x as the smaller quantity is so that the larger quantity can be x plus 20, just so that I don't have a negative sign, because any negative sign gives you the chance of forgetting about that negative sign and forgetting to distribute it somewhere. Okay, so it's just easier to have x and x plus 20 than it is to have x minus 20 and x. Okay. Now that we have distance and speed, once you have any two columns of this table filled out, you can use the formula that relates distance, speed, and time to find the third column. So time is going to be distance divided by speed. So we'll just take our distance divided by our speed, and we have our time written in symbolic math notation. Sure, we don't know what x is yet, but we do have the time of the car and the time of the truck written in terms of x. And we also know that the time the car was driving and the time the truck was driving are equal. We can use that final piece of information to set up our equation, right? Once we have our equation, it's a proportion. We can cross multiply and then solve for x. So we get that x is 40. That's not our answer yet. The question is, how fast is the car going? How fast is the truck going? We used x to represent the speed of the truck. So the speed of the truck is 40 miles per hour. We can see from our table that the speed of the car is x plus 20. So the speed of the car is 60 miles per hour. Now you can always go back and check. All right, if I travel 40 miles an hour and I cover 120 miles, how long is that going to take me? It's going to take me 3 hours, right? If I travel 60 miles an hour and I cover 180 miles, it's going to take me also 3 hours. So yeah, all this stuff checks out. Okay, so those are distance, rate, time problems. Always set up that table, list the stuff you know, use a variable for the unknown to relate the two quantities, and then figure out what you know is equal to set up your equation. Okay. That is chapter 7.6. Take your time to go through this material. Good luck with anything, and let me know if you have questions.